Hey, today we're going to talk about 9.4, increase in greenhouse gases. So take a moment, check out the Enduring Understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. So greenhouse gases have been increasing since the Industrial Revolution, and through anthropogenic sources we've actually increased the amount of greenhouse gases and the different types of greenhouse gases. And being mindful of that is necessary and to make changes so we don't continue to see this impacting overall climate change. And what I would like to point out is that one of the major impacts is going to be sea level rise. And this affects us in New York City because we live on a coast. And from projections, this is like what downtown Manhattan could look like with if the projections are true with sea level rise. This is just an image I pulled off the internet. I don't know how many, inches or feet this is in sea level rise. But with the melting polar ice caps, now this refers to ice sheets that are on land. Like Greenland is, basically a giant glacier. Antarctica, basically a giant glacier. This is not talking about ice that is on the Arctic Ocean. So it also doesn't include any ice from icebergs. So if it is ocean water that has an area that is frozen over the top, like the Arctic Ocean freezes in the winter, and parts of it are frozen throughout most of the year, and that ice will not contribute, if it melts, will not contribute to sea level rise. I'm talking specifically about the ice in the Arctic regions that is over land. Okay, that will contribute to excess water building up in the oceans. And another thing, when the oceans get warmer, molecules are moving. Water's polar, it kind of reorients itself as it moves because the hydrogens don't like to talk to each other. The hydrogens and the oxygens will communicate with each other because they have opposite signs, positive and negative. So when the water moves around faster, it eventually is going to expand. So this thermal expansion is what we call it. And ocean water the levels will rise just because the ocean is warming up. So because the water molecules are moving faster, eventually they're going to move a very slight, distance apart. And when you add up all of the water molecules that are present in the ocean, it does add up, and that will cause sea levels to rise. So these two things are working together, and it is making the problem a lot worse. So this is a positive feedback loop. We melt the polar ice, and once the polar ice is melted, like especially the water in the Arctic Circle, is going to expose more ocean water. So when you expose more ocean water, remember that is a very low albedo. That dark Arctic water will absorb sunlight and infrared radiation from the sun, and it will cause the ocean waters to warm. And since the ocean water is warm, it will melt the ice around it. So this is a positive feedback loop because it's a self-perpetuating cycle. So the sea level, this is a little graph for the last 25 years. Sea levels have risen, and this is a level of just a global sea level, and this is from satellite readings. This is the amount of sea level rise from thermal expansion, and this right here is added water, and it's meltwater, pretty much from the polar ice caps and the glaciers. And then everything put together, added water and thermal expansion, is this little purple graph. So you can see that in the last 25 years, the sea level has risen. I mean, since the early 90s, it's risen, 9 centimeters, which is, about, almost 5 inches. That's a significant amount. And it doesn't seem like a lot, but it doesn't take much in order for us to see those impacts eventually, like especially over the last few years, the amount of storms that we've had, the storm surges that have come in from hurricanes, the amount of tropical storms that have actually hit New York, like that's kind of, the sea level, higher sea levels is going to impact that. Okay, so with the sea level rise comes a bunch of different impacts, and one of the things, like I showed you in an earlier slide, was flooding of coastal areas. Now this can affect cities, but also it can affect habitats that are located along coastal areas. Recall that mangrove forests are common in coastal areas, especially in the tropics, and they're designed or they're evolved to live in the intertidal zone. And if the sea level rises too much, you will impact could impact their photosynthesis. A lot of the plant could be submerged, and they are not adapted to live in water that is too deep. So you'll find these mangrove forests, if the sea level rises too fast, these mangrove forests cannot, naturally migrate farther inland. Sometimes it just may not be possible. In addition, you may have also habitats being destroyed from ocean water going into and submerging plants that are not adapted to have salt water on them. So you'll also lose species especially species that are found in the Arctic sea ice, like polar bears. Polar bears live on the sea ice, and as the sea level rises, more of this polar ice is going to melt, leading to this positive feedback loop. So organisms that depend on these tundra ecosystems, where the permafrost may be melting, all of this is habitat destruction, and that could lead to loss of species. So we're going to have more intense hurricanes. This is because when the sea levels are rising, you're also having this thermal expansion, which means the waters are getting warmer. And because the waters are warmer, there's going to be more fuel for these hurricanes. When there's more evaporation, that's more moisture in the atmosphere, that leads to more potent storms. There's going to be an increase in flood frequency. So floods are going to happen a lot more often, and that means insurance costs are going to go up. Property damage will increase. You'll also it'll be more expensive to build buildings because you're going to have more flood controls that need to be implemented. In addition, like raising houses up on stilts in coastal areas. If you've ever been to beach towns in Long Island or down parts of the Rockaways, you'll see that houses are getting jacked up. Long Beach especially, out in Long Island, they're getting moved up onto these higher stilts. And that is to prevent these storm surges that may come from maybe a hurricane or any sort of ocean or coastal flooding. Also, when the sea level rises, there's more salt water pushing into the fresh water inland. And recall back to, I believe it was in Unit 5, but it was saltwater intrusion. We talked about it when we were discussing agriculture. So when you have more ocean water than you do groundwater, that salt water is going to push in. So we discussed before, by removing the groundwater, the salt water will push in. But now the salt water is rising. Doesn't say anything about depleting the aquifer, but there's going to be more pressure for this ocean water to push in, and that could lead to obviously it could affect drinking water, especially in a lot of coastal areas. And finally, there might not be cities in a lot of these countries and cities with very low elevations. Like parts of Bangladesh has very low areas and a lot of high population. So there may be a lot of environmental refugees. People living, for example, down in Florida, a lot of Florida, the Gulf Coast. People will be moving inland. And if you have people moving from one country to another, we already have problems, people coming from Central America. We have ongoing issues at the southern border. Like, just imagine what's going to happen if you have a lot of people that have to find a place to live that's going to be more suited for them. So this brings me to another point, is we have disease vectors, like for example mosquitoes. Mosquitoes live in these tropical regions, and these are the mosquitoes that cause, I don't remember, this could be either yellow fever, dengue fever, or malaria. It doesn't really matter, but this is the range that they live, and this is how many months these mosquitoes can affect. So if you look right now in 2019, maybe 1 month we can be affected, 2 months by mosquitoes. I don't really know where New York is technically on there, but as climate change and the greenhouse effect becomes more pronounced, Global temperatures will increase, which will mean that these vectors can now shift. So by 2050, there could be areas well up into Canada, well up into northern parts of Russia, Siberia, parts of Scandinavia that never had problems. Notice they never had problems with mosquito vectors, with these disease vectors. Look, most of Europe now in 2050 will have to deal with diseases like malaria. And then by 2080, up in Alaska, even Norway and Sweden and Finland could be definitely impacted by these disease vectors. So as the temperatures increase, global temperatures increase, these disease vectors can find a widened range, which is a problem. Also, we might find population shifts. So right now, this is a suitability index. In other words, these dark colors indicate comfortable areas for people to live. And I think this little dotted line is like the limit. Like, okay, this is like no man's land. Granted, people do live up here, but it's not the most ideal environment. And so this is low suitability, and then these are high. So we have, parts of Central Asia, most of Europe, most of the, southeastern, or most of the United States actually. But now look at what happens in 2070. Now this population shifted, so where it was suitable down here in parts of the southeast, now it's becoming areas around the Great Lakes. We might be in the most ideal environment. Most of Europe now is in an ideal environment, the most suitable. But once this population or the climate change keeps continuing to get worse, these population shifts are going to be even more pronounced. So this is the suitability change. So some places are going to be more suitable to live. In fact, most of the northern United States will be more suitable. The southern United States will be less suitable. This yellow colors indicate that there's really not much of a change. A lot of, the Sahara Desert's going to be even more difficult to live. Most of India will be less suitable. Most of, Brazil will be less suitable. So there are these shifts. A lot of Europe may be, a more comfortable place to live. In fact, you'll also notice that different countries that grow grapes to make wine, there's different countries that are now wine countries. 50 years ago, you never would have drank a wine from England. But now England, United Kingdom, has wineries. And, places like Spain used to have wineries, and France. But now they're going to become not as suitable for growing the grapes required to make the wine. So as the population shift, also the climate will shift. You will also see wine production could shift from different countries. So countries like maybe eventually Norway is going to be a world leader in wine production. Hopefully that doesn't happen, because that means that the climate has changed so drastically. Okay, I gave you a lot of information. Let's try to practice some of that with writing. So I want you to identify an area where malaria rates have increased and explain how climate change has contributed to this increase. I thank you for your attention. I hope that this was informative. I will see you soon.